Okay, so we're going to do 8.2 today. 8.2, estimating a population proportion. So estimating population proportion is basically this. So we're going to do from a population, we're going to take a simple random sample, and we end up with a sample here. Population size n, sample size n. We have a true proportion here. So this is what we're trying to estimate. We're trying to estimate this by using the p hat, the sample proportion that we found here. Okay? And we know that the sigma here, and we've already learned this, was p hat 1 minus p hat over n. Okay? So the way we do this, and if we do so in order to find the actual confidence interval, we would find that it is p hat plus or minus a critical value over p hat 1 minus p hat over the sample size. Okay? In order for this to work, three things or three conditions have to be met. The three conditions are, first of all, it has to be a simple random sample. Number two, the sample size itself cannot be greater than 10% of the total population. You cannot oversample. And three is what we call the large counts, and we are all familiar with this. The large counts, NP and N1 minus p hat, both have to be greater than 10. Okay? So these are things that we've already talked about. We're putting them together here. So if you think about it, what out of this equation to do a confidence interval is hard? Well, this is nothing more than what we got here, just as this and this are, okay? This is nothing more than the number that we sampled, so that's also easy. We just put it in the equation. The only thing that's going to give us any kind of problem here is this guy here, finding the actual critical value, okay? To find that critical value, all right, we are going, so in order to find, let's go look at finding the critical value itself. To find the critical value itself, all right, we'll be looking at a normal distribution, and the normal distribution is going to look like this. And you're going to be, let's say we're going to do a 95%. 95%, 95%. So in other words, in here, you want the 95% here and here. In other words, it is a two-tailed, or two things here. So for this in middle to be 95%, that means that each of these have to be 2.5%. Okay? So you would want to find the z-score here that gives me 2.5%. Okay, two ways to do this. I can do the table. I can look at the table, or I can do an inverse norm and say 95% when this is 0 and my standard deviation is 1. All right? And if I do that, I get negative 1.96. In other words, the z-score here is negative 1.96, which means that the z-score here has to be positive 1.96. In other words, my critical value here is going to be 1.96. And the rest you would just go ahead and put in. And that'll give you your confidence interval. Okay? So let's go ahead and look at how we can do this. So let's go to page 513. In the middle there's a green box that says the conditions for constructing a confidence interval. And there are the three conditions: a random sample, I already assumed there has to be a random sample, less than 10%, and sampling less than 10%, and the large counts. Okay? So let's look at the example there. The beads. Mr. Buckley's class wants to construct a confidence interval for the true proportion of red beads in the container, which contains over 3,000 beads. Recall that the class's sample of 251 beads had 107 red beads and 144 other beads. Check the conditions. So let's check the conditions. Conditions are, number one, it has to be a random sample. And it is a random sample there. There's no reason why that we can believe that it's not. And then we sampled 251, and there were over 3,000. So 10% of 3,000 is 300, and that's less than that. So we definitely did not oversample. Okay, and then the n is the number of our sample. That's with large counts. N times p hat would have been the number of red. And then the non-red, the number of the others, would have been 144 over 251. This is 107. This is 144. They are both greater than or equal to 10. So the large counts works. Okay, so we're good to go there. And that's how you would check the number, check the large counts condition here. Okay? So, let's go ahead and do the example on page 516. On page 516, let's go and read the question. The question says, according to a 2016 Pew Research Center report, 73% of the American adults have read a book in the previous 12 months. Okay? A book, right? The estimate was based on the random sample of 1520 American adults. Assume the conditions for inference are met. So then we do not have to check the three conditions. A, determine the critical value of our Z star for a 90% confidence interval. So a 90%. So we're doing a 90% here. So we're doing 90%, which means that both sides have to be what? To get 90 in the middle, both sides have to be 5, right? 5 here. So to find the Z star, I can go inverse norm, 0.05, 0, and 1. Okay? And if I do that, I get 1.645, negative 1.645. Okay? You can also do this with the table, right? Okay, so just realize you can do that. So you have negative 1.645. So the Z value here is negative 1.645, positive 1.645 here. Okay. B, construct a 90% confidence interval with a proportion. So let's go ahead and do that. So the confidence interval itself is going to be what? Here we have 0.73, the 73% of American adults. Z score was 1.645, 0.73, 1 minus 0.73 over 1520. And if I do that, I'm going to get 0.711, 0.749. 0.711, 0.749. Okay? C, interpret the interval. And this always, like I said, this one always comes up, right? To interpret this, we're going to say that we are 90% confident that the interval 0.7112 to 0.749 captures the true proportion of American adults who have read one or more book in the past 12 months. Okay? And that will be good for today.